Hello and welcome to my YouTube channel. Today I shall be teaching the topic partial fractions. Please kindly hit on the subscribe button below to subscribe to my channel if you've not done so already. Thank you. Partial fractions are used to decompose a complex rational expression into two or more simpler fractions. A partial fraction is a reverse process of the addition of rational expressions. Now let me try to make meaning out of what we've just read. A few grades before now, we often encounter problems like simplify 2 over x minus 2 plus 3 over x plus 1. So let us try now to solve this again and see where it leads. So we write out 2 over x minus 2 plus 3 over x plus 1. We take the LCM. So the LCM of x minus 2 and x plus 1 is x minus 2 and of course x plus 1. So if x minus 2, x plus 1 divides x minus 2 will cancel x minus 2, and what is left is what? X plus 1. Then x plus 1 times 2 is 2 into x plus 1. Plus, if this LCM divides x plus 1, this factor will cancel this one. And what is left is x minus 2 times 3 is 3 into x minus 2. I guess you're familiar with this process already. So if we expand the numerator, we have 2 times x is 2x, 2 times 1 is plus 2, 3 times x is plus 3x, 3 times minus 2 is minus 6. Divide by, if we expand the denominator also, we get x times x squared, x times 1 plus x, minus 2 times x minus 2x, and finally minus 2 times 1 is negative 2. If we tally it up one more time, we get 2x plus 3x is 5x, 2 minus 6 is negative 4, divide by x squared, x minus 2x is negative x minus 2. So what have we done? We were given two simple fractions here and we're asked to simplify, to add up. Then we took the LCM, and at the end of the day we landed at this fraction 5x minus 4 divided by x squared minus x minus 2. Now these two fractions you see here are these are the partial fractions of this compound fraction. So I want to call this fraction here a compound fraction, and we call these guys here the partial fractions to this guy. So what are we doing here in partial fraction? Very simple. In this topic, we shall be given compound fractions of this nature, and we'll be asked to split into partial fractions like this. Or you're given a compound fraction and you're asked to resolve into partial fraction. So that would simply mean to do the reverse of this process. So in partial fraction, therefore, you'll be given compound fractions and you expected to get the partial fractions that make up the compound fraction. Now, why is this necessary, to go through all this? It is because this topic, partial fraction, is really applicable, especially in the topic integration. There's something called integration by partial fraction. There, you are asked to integrate something like this, say the integral of the whole of this with respect to x. And it will become very difficult, to integrate this unless or until we resolve what we have into partial fractions. It now becomes easier to integrate these terms rather than this. So going forward, our very first example will be to resolve this into partial fractions. So that we will see that indeed the partial fraction of this guy, 5x minus 4 over x squared minus x minus 2, will be 2 over x minus 2 plus 3 over x plus 1. Now, in splitting a compound fraction into partial fractions, we shall pay attention to the denominator of our rational expression only, to the denominator. That is to say that the nature of the denominator of your compound fraction determines how you solve, or how you resolve the compound fraction into partial fractions. And of course, there are three distinct cases, that can be treated depending on the nature of the denominator. We shall take these cases one after the other. But before then, I'd like to introduce something that will help us, going forward. Now, if I write ax cubed plus bx squared plus cx plus d, this would be a general polynomial of degree 3. Okay, a general polynomial of degree 3. So if I were to write it as a general polynomial of degree 2, then I'll strike off the first term and it will become bx squared plus cx plus d. So this will now be a general polynomial of degree 2. If I were to write for a degree 1, I'll strike off the first term and it will become cx plus d. And this will be a general polynomial of degree 1. If I were to write for degree 0, I'll strike off this and I'll just write a constant d. So while this is a polynomial of degree 3, this is a polynomial of degree 2, polynomial of degree 1, and of course polynomial of degree 0. In other words, for a degree 3 polynomial, the highest power of x present is always 3. So you have 3, you have power 3, you have power 2, you have power 1 and 0. While for a degree 2 polynomial, the highest power of x present is 2. And after 2, you have 1, then 0. No, we can write here x to the power 0. Then for a degree 1 polynomial, the highest power of x, is 1. And we also call this linear. The highest power of x is 1, and then there's x to the power 0 here. While for a degree 0 polynomial, there is no x at all. Now, this idea will help us, when trying to split our partial fractions. As a way of remark, throughout this lesson, we shall be treating only partial fractions or fractions that are proper. We say proper fractions. Now, when we say a fraction is proper, it simply means that the degree of the numerator is strictly less than the degree of the denominator. And a fraction will be said to be improper if the degree of the numerator is the same or greater than the degree of the denominator. I'll just show you two examples. Now, for the first fraction, x minus 1 divided by x squared plus 4. This fraction is a proper fraction because the highest power of x in the numerator is 1 and the highest power of x in the denominator is 2. So the degree of the numerator is less than the degree of the denominator. That makes this fraction proper. For the second fraction, x squared plus 2x over x squared plus 1. This fraction is an improper fraction because the degree of the numerator is 2. The degree of the denominator is also 2. So this is not what we're talking about. So the degrees of the numerator and the denominator are the same. Hence, it's not a proper fraction. And of course, for the third example, the same thing, improper. The degree of the numerator is 3 and that of the denominator is 2. So 3 is greater than 2, hence an improper fraction. So I am saying that we shall be dealing only with fractions that are proper. However, for improper fractions, we have to employ, the long division process of polynomials first before we are able to proceed. And that's not what we'll be doing for today. Now let's look at the three cases, we had earlier discussed. Case 1 is when the denominator has linear factors. Recall, we are only talking about the nature of the denominator. So case 1 is when the denominator has linear factors. Now let's look at it. Now look at this compound fraction, for example. mx plus n divided by, the first factor here is ax plus b. Second factor is cx minus d. And the next question is, are these factors linear factors? We can check and know. How would you know if a factor is linear? The highest power of x in each factor will be what? Will be 1. So for the first factor, we have ax plus b. This is x, and the highest power of x is 1. So the first factor, ax plus b, is a linear factor. The second factor is cx minus d. You check again if it is linear or not. The highest power of x in this factor is 1. Hence, the factor is a linear factor. That is to say that our compound fraction here has two factors that are both linear. So when we have such a situation, what do? Now we're going to suggest what the possible partial fraction should be, or what we call, we're going to decompose this into some fractions. Now the following: this common fraction will now be equal to, like I want to do it, the first factor is ax plus b plus the second factor there is cx plus d. It's now time to figure out what will be in the numerator or denominator. you pay attention. Now, ax plus b is a polynomial of degree what? I had discussed this, a little a while ago. Where I said this is a polynomial of degree 3, degree 2, degree 1, and degree 0. Okay, so we're going back to this idea. So here, obviously, this factor is a degree 1 polynomial because the highest power here is 1. So that will tell us what should be up. So the trick is this. Since the highest power of x is 1, or the factor here is a degree 1 polynomial, what we write up here will be a general degree 0 polynomial. That is to say that what you write up here must be a degree, must be 1 degree less than the degree of the denominator. What does this mean? It means that if the denominator is a polynomial of degree 3, the numerator will be a polynomial of degree 2. If the denominator is a polynomial of degree 8, the numerator will be what? A polynomial of degree what? 7, and so on and so forth. So in this case, ax plus b is a polynomial of degree 1. So I will now write a general polynomial of degree 0 up, and that will just be something like a. You can use d, you can use f, whatever it is you like. A is clearly a polynomial of degree 0 because a simply means ax to the power 0, and this is a polynomial of degree 0. So the denominator is a polynomial of degree 1. The numerator has to be a polynomial of degree or 1 degree less than the degree of the denominator. If you go with this, then there will be no issues going forward. We come to the next factor, cx minus d. And again, this factor is linear or a polynomial of degree 1 since the highest power of x is 1. So what should be up? It must be a polynomial that is 1 degree less than this. So it will be another polynomial of degree 0. Since we have used a already, we use another alphabet, say b. So when we have a compound fraction whose factors are linear, then we decompose into a over ax plus b over cx minus d. And our job now will be to determine the values of a and b. Once we get the values of a and b, we come back here and put them into a and b, and that gives us the required partial fractions. If you observe, you see that we have paid no attention whatsoever to the numerator mx plus n. Our only concern is on the denominator, as long as the fraction we are dealing with is a proper fraction. For instance, if we were to split the compound fraction 3x plus 2 over x plus 2 into x minus 3 into its partial part, what would it be? We go to the denominator straight up. X plus 2 is a linear factor because the highest power of x is 1, so it's linear. And then here also x minus 3 is also a linear factor for the same reason. So we have x plus 2 as the first factor plus second factor is x minus 3. Since this factor is a polynomial of degree 1, the numerator will be a polynomial of degree 0, and that will just be a. Here again, this is a polynomial of degree 1, so up will be what? A polynomial of degree 0, and that will be b, and that's all. We'll now carry out other steps to find the value of a and the value of b. Case 2 is when we have repeated linear factors, again where? At the denominator. So we have here mx plus n divided by, the first factor is ax plus b, second factor is cx minus d, but now is squared. Now the first thing is, are the factors linear? Let's check. Ax plus b is a linear factor. The highest power of x is 1, so it's linear. Second factor is cx minus d, and again is linear. However, we have cx minus d raised to the power 2. So this simply means that this factor, cx minus d, is repeated. So this is a case where the factors involved are linear, but one of the factor is repeated. Recall, if we have x squared, this simply means what? X times x. So x is repeated twice, right? Good. So that happens here. So when we have a case where one of our factors is linear but repeated, then we'll do the following. The first factor there is ax plus b, plus second factor is cx minus d. Because it's repeated, we put it or write it down the second time, cx minus d all squared. And of course, If there's a cube here, we write the third time. We now go up and figure out what should be at the numerator. Don't forget. So for the first one, we have ax plus b, linear factor, or a polynomial of degree 1. So what should be here? Should be a polynomial of degree 0. That is simply a. This is also a polynomial of degree 1. So we'll bring in a polynomial of degree 0 here. That is simply b. And this again is a polynomial of degree 1. We bring in a polynomial of degree 0, and that will be what? C. And our job now will be to determine the values of a, b, and c. For instance, if we're to split 3x minus 5 divided by x plus 2 into x minus 3 raised to the power 3 into partial fractions, what would be, our partial fractions? Let us see. So the denominators are x plus 2 is a linear factor. X minus 3 is also a linear factor, but repeated how many times? 3 times. So the first factor there is x plus 2. Second factor is x minus 3 is repeated. So how many times? 3 times. Second time is x minus 3 all squared. And the third time is x minus 3 to the power 3. I guess you understand. You see the sequence now. So if we had 4 here, we'll add the fourth power. We'll now figure out what should be up. This is a polynomial of degree 1, so degree 0. Degree 1 polynomial again, degree 0. X minus 3 is also degree 1, so degree 0. X minus 3 is degree 1, so this is what? Degree 0. So we have A, B, C, and D, which we are going to determine. And once we get the values of A, B, C, and D, then our partial fractions are ready. Case number 3, and that is the last, is a case where the denominator has quadratic factor that cannot be factorized. Now, of course, what does that mean? It simply means that there are some factors that are quadratic and can be factorized, while others cannot be factorized. For example, we have the fraction mx plus n divided by ax plus b into x squared plus d. Now, the first factor here, ax plus b, is a linear factor. How is it linear? The highest power of x is 1, so that is linear. The second factor is x squared plus d. Here the highest power of x is 2. And that makes this, this factor to be quadratic. So a quadratic factor is a factor whose highest power of x is 2. So here we have a quadratic factor. Now the method we're going to apply here is a method in which the quadratic factor here cannot be factorized, because some can be. And of course, where it is factorizable, it is advised that we should always try to factorize. However, some will not be factorizable. And when that happens, we write the following. So, our first factor is ax plus b, plus our second factor is x squared plus d. So this factor is linear. That means it is of degree 1. It's a polynomial of degree 1. So what should be up? A degree 0 polynomial, we'll simply write a. The next factor is x squared plus d. And this factor is quadratic, which simply means that the highest power of x is 2. Using the same method, what should be up? What should be up here should be a polynomial of degree 1. Remember, our polynomial here must be 1 degree less than the one down here. This was degree 1, this is degree 0, this is degree 2. We must put degree 1 here. We have already used a. So degree 1 will now be bx plus c. And now our job will now be to determine the values of a, b, and c. And with that, our partial fractions, are ready. For instance, if we have the compound fraction 3x squared minus x plus 8 divided by x plus 4 into x squared plus 4. This will be a case where we have one factor that is quadratic. And not just quadratic, this factor is not factorizable. If it were, how would it look like? Let's see something. If we had x squared minus 4, it would be factorizable. How? Because we could write this as x squared minus 2 squared. And we can now apply the difference of 2 squares here. And this becomes x minus 2, x plus 2. So this means we factorize, x squared minus 4. But in this form, x squared plus 4, this factor is clearly not factorizable. So this is a kind of, this is a situation where we have a quadratic factor that is not factorizable. So, or that cannot be factorized. So what do we do? So the first factor here is x plus 4 plus second factor is x squared plus 4. This is a degree 1 polynomial. What will be up here will be degree 0. We'll simply write A. This is degree 2 polynomial. What will be here will be degree 1. We'll now write, we've already used A, we'll now use B, X plus C. We'll now find the values of A, B, and C. Now, what if our quadratic factor, was repeated? How will we treat it? The same. This becomes, the first factor is x plus 4 plus second factor is x squared plus 4. Since it's repeated, we bring it in. X squared plus 4 all squared. In the same way we had handled the case of linear but repeated factors. So this is degree 1 polynomial. Up will be degree 0. This is degree 2. Up will be degree 1. So this is bx plus c. This again is degree 2. Up will be degree 1. So we have already used A, we've used B and C. We can now use different alphabets. So we can use D, X plus say E. We'll now find the values of A, B, C, D, and E. You should recall at the beginning that we had simplified, 2 over x minus 2 plus 3 over x plus 1, and we got the compound fraction 5x minus 4 divided by x squared minus x minus 2. So as a first example, we shall see if this can be resolved to get back these partial fractions. So example 1, split 5x minus 4 over x squared minus x minus 2 into partial fractions. So like I explained earlier, our interest is always, on the denominator. So we have here x squared minus x minus 2. This is clearly a quadratic factor. But you must also ask yourself a question. This quadratic factor here, is it factorizable or not? Can it be factored? If the answer is yes, rather, if this can be factored, then you must always factor. It's a must. You must always factor. And when this cannot be factorized, then you leave it the way it is and apply case 3 on it. So x squared minus x minus 2 can be factored. So we have here x squared minus x minus 2. We have two numbers whose sum is minus 1 and whose product is minus 2. If we have, then we can factorize. And we have. So we have minus 2 plus 1 is minus 1. And minus 2 times 1 is minus what? 2. So we can factorize. So this becomes x squared minus 2x plus x minus 2. We can now put them in pairs and factor out. What is common here is x. We have here x minus 2 plus 1, x minus 2. So x times x is x squared. X times minus 2 is minus 2x. 1 times x is x. 1 times minus 2 is minus 2. So this becomes x minus 2 into x plus 1. So we have factorized the quadratic expression, in the problem. So that becomes 5x minus 4 over x squared, rather x minus 2 into x plus 1. So this quadratic factor, which was initially in the problem, has been split or has been factorized, and we now have two linear factors. So the next thing now is to check which of the cases, does this factor, or do these factors, belong, and that determines how we go about solving it. If you look critically, you see that there are two factors here. The first factor is x minus 2 and is clearly a linear factor. The second factor is also x plus 1, and this factor is clearly a linear factor. So this takes us to case number 1, which says case of what? Linear factors. So we'll now proceed with the solution. So now we have 5x minus 4 over x minus 2 into x plus 1 to solve or to resolve. So the first factor is x minus 2. I put it down here. X minus 2 is my first factor. The second factor is x plus 1. I put it here. X plus 1. In a moment, you will know why I'm leaving these spaces. Good. Now, to the first factor. This factor is linear. That is to say that the highest power of x is 1. So what should be up? It should be a polynomial of degree 0. So I just simply write A. Second factor is also linear. That is the highest power is 1. So what should be up? A polynomial of degree 0. And I put here B. And that is it. We'll now proceed now to find the values of A and B. So, solution. Now at this point, the first thing I'm going to do is to try to clear the denominators. So what do? I will multiply, each of these terms by the denominator. X minus 2, x plus 1. So I multiply here by x minus 2, x plus 1. Multiply this factor by x minus 2, x plus 1, multiply this other factor by x minus 2, x plus 1. If we do that, we'll now see that this factor will cancel this. This one will knock this one off. X minus 2 will knock x minus 2. X plus 1 knocks off x plus 1. And what is left? We now have 5x minus 4 is equal to a into x plus 1 plus b into x minus 2. So at this point, we now choose to find the value of a and b. So we may take the value of a first, then b later, or b first, then a later. It doesn't really matter. So the best way to approach this is by one, if we choose to find the value of a first, then we must force the value of b to be 0. And the only way to do that, to force b to be 0, is by getting the 0 of x minus 2. What does that mean? To get the 0 of x minus 2 simply means to make here 0. And to make here 0, you just say x minus 2 equal to 0. And then find the value of x. If x minus 2 equal to 0, then x is equal to 2, right? Good. So if we put the value of x here as 2, we'll have 2 minus 2, and that will be 0. And then 0 times b will be 0. With that, we'll be able to find the value of a. Then we'll do the same thing, for a to find the value of b as follows. So the first one is we're going to put x equal to what? 2. Now to do that, we put x equal to 2, everywhere. So from the left side, we have 5 into 2, since x is now 2, minus 4 equal to x, a rather, into x is now 2 plus 1, plus b into x is 2 minus 2. So 5 times 2 is 10 minus 4 equal a, 2 plus 1 is 3, plus 2 minus 2 is clearly 0, so that 0 times b is 0. And that was the essence of doing all this. So 10 minus 4 is 6 equal to a times 3 is 3a. Of course, this is 0, so it's gone. We now have this. So we can now divide both sides to find the value of a. We now divide both sides by 3. Divide both sides by 3. So we have that a is equal to what? 6 divided by 3. A is equal to 2. Now we have the value of a as 2. We go back, to equation star to find the value of b. We now check again to see that this time, if we make, this bracket to be 0, a will be eliminated, and we can find the value of b. Of course, there are many ways. There are several ways to carry out, this operation. I'll show you one or two, as we go forward. So to make, this a 0, I'll find the 0 of this again. So I'll simply write x plus 1 equal to 0. If I solve for x, I'll have x equal to negative 1. So if I put x as negative 1, then a will be 0. I can find the value of b. So once again, I now say I'm going to put x equal to what? Minus 1, negative 1. So from the left hand side, I will have 5 into negative 1, 5 into negative 1 minus 4 equal to a into minus 1 plus 1 plus b into x is minus 1 minus 2. So 5 times minus 1 is minus 5 minus 4 equal to minus 1 plus 1 is 0. So that 0 times a is 0. Plus minus 1 minus 2 is minus 3. So plus b into minus what? 3. So if I take this up here, I'll have minus 4 minus 5 minus 4 is negative 9 equal to b times minus 3 is negative 3b. To find the value of b now, we can divide both sides by minus 3. Divide by minus 3. So that b is equal to minus cancel minus. 9 divided by 3 is simply what? 3. So I have my value of a as 2 and b equal to what? 3. So we'll now go back to our fractions that we had earlier, splitted. We had splitted 5x minus 4 over x minus 2, x plus 1 into a over x minus 2 plus b over what? X plus 1. And now the value of a and b, the values of a and b have been found. So a is 2 and b is 3. So a is 2 and b is 3. So we'll now go back to our splitted fraction and replace a with 2 and b with 3. So this now becomes a is 2, so this is 2 divided by x minus 2 plus b is 3 over x plus 1. When we go back to that first illustration, we now see that indeed the partial fractions have been obtained. 2 over x minus 2 plus 3 over x plus 1. So these are indeed the partial fractions of the compound fraction 5x minus 4 divided by x squared minus x minus 2. Example 2. Resolve 2x plus 1 over x plus 1 x minus 1 all squared into partial fraction. So here the compound fraction is 2x plus 1 divided by x plus 1 into x minus 1 all squared. We now check the denominator to find out the nature of the factors. So the first factor is x plus 1, and this factor is clearly a linear factor. The second factor is x minus 1, and this factor once again is a linear factor. However, the factor x minus 1 is repeated because we have it twice. So this is a second case where we have linear and repeated factors. So we split as follows, equal to, so we have the first factor is x plus 1. Second factor, by now you should know why I'm keeping the space. Second factor is x minus 1. Since it's repeated, the third factor there is x minus 1 to the squared. So we now fill out what should be, in our numerators. This is a degree 1 polynomial. So what should be up is degree 0 a. This again is degree 1. What should be up is degree 0 b. This again is linear or degree 1. What should be up is degree 0 c. It's as simple as that. After doing this, we now proceed to find the values of a, b, and c. And once those values are obtained, we'll come back to this line, substitute the values for a, b, and c. So like we did before in the previous example, I'll start by clearing what the denominator. So I simply do that by multiplying each of the terms or each of the fractions by the denominator x plus 1 times x minus 1 all squared. I multiply this by x plus 1, x minus 1 all squared. Multiply this one also by x plus 1, x minus 1 all squared. Multiply the third one also, x plus 1, x minus 1 all squared. And the last one, x plus 1, and then x minus 1 all to the squared. So here, this will knock off, and then over here, x plus 1 knocks off x plus 1, and over here, there are two of these, x minus 1 all squared. So this will knock off one of these, and you have one left. You see, have one left there, x minus 1, since there are two. And the last one, x minus 1 all squared, knocks off this completely. So what do we have left? Let's write it down. On the left hand side, we have 2x plus 1 left equal to, over here we have a into what? X minus 1 all squared plus b into x plus 1. Second factor is x minus 1 plus c into, we have x plus 1. So we call that our equation star. So once again, we now have equation star to solve, and our job here is to find the values of a, b, and c. So we can still approach it, using the method we used earlier, where we find the zeros of this, we found the zeros of our brackets. So we can decide to find a, before b, or however you want to do it is okay. And like I said earlier, there are different ways, to carry out this solution from this point. So let us see what we can do. I have seen already that if I make x to be minus 1, c will be eliminated. I've seen that already. So once I've seen something like that, I'll just put it in. So let's see what happens. So if you set x plus 1 equal to 0, you have x equal to minus 1. So if I put x equal to minus 1, I'm sure that this will be 0. And of course, this will be 0 too. Let's see what happens. So this becomes, left hand side becomes 2 into x is now minus 1 plus 1 equal a into minus 1 all squared plus b into x is minus 1 plus 1, x again is minus 1 plus c into x is minus 1 plus 1. So 2 times minus 1 is minus 2 plus 1 equal a into minus 1 is minus 2 all squared, plus, now minus 1 plus 0, rather minus 1 plus 1 is 0. This is clearly 0. And if this first bracket is 0, then everything here will be 0. Because if this is 0, 0 times b is 0, and then 0 times whatever is here is also 0. So the second term here is 0. Plus minus 1 plus 1 again is 0. So that 0 times c is 0. So what we have left is minus 2 plus 1 is minus 1 equal to minus 2 squared is 4. 4 times a is 4a. And to get the value of a, we divide both sides by 4. So I divide both sides by 4. So that a is equal to what? Negative 1 by 4. So we have found the value of a by simply putting x equal to minus 1. Let us check again. Can we put x as something else? Yes, we can. I've seen here that if I put x as 1, this will be 0 also. So if x minus 1 equal to 0, so x equal to 1. So if I put x, as 1, I'll also have a 0 somewhere. So we're now going to put x equal to 1 into equation star. So put x equal to 1 into star. So left hand side is 2 into 1 plus 1 equal a, this is 1 minus 1 all squared, plus b into 1 plus 1, 1 minus 1, plus c into 1 plus 1. So 2 times 1 is 2 plus 1 equal 1 minus 1 is 0. So once here is 0, 0 times a will be 0. Plus 1 plus 1 is 2. 1 minus 1 is 0 again. Here will be 0. And once here is 0, 0 times 2 times b again is 0. Plus 1 plus 1 is 2. 2 times c is 2c. So what we now have is 2 plus 1 is 3 equal to 0 plus 0 plus 2c is simply 2c. And to find the value of c, we will divide both sides by the coefficient of c, which is 2, so that c is equal to 3 over 2. So we have found the value of c as 3 over 2. And initially, we already had the value of a as minus 1 over 4. So what is left? We have found the value of a, we found the value of c. We are left to find the value of b rather. But you observe here that we can't make any other 0 here. So what you now do at this point is to simply, one of the ways of carrying out at this point is to simply put the value of x as a very, simple number that I can easily handle. So we have put the value of x here as minus 1. We have put the value of x again as 1. So I like to put the value of x as 0. Put x equal to 0 into equation star. Since we already used minus 1 and 1. Though this doesn't make any 1 0, but you simplify our problem in such a way that we can carry on from there. So let's proceed. So we have here left hand side 2 into 0 plus 1 equal to a into 0 minus 1 all squared, plus b into 0 plus 1, 0 minus 1, plus c into 0 plus 1. Let's simplify this. So 2 times 0 is 0. What is left there is 1 equal a, 0 minus 1 is minus 1 all squared, plus b, 0 plus 1 is 1, 0 minus 1 is minus 1, plus c into 0 plus 1 is 1. So we have 1 equal to minus 1 all squared is 1. 1 times a is a. Then minus 1 times 1 is minus 1. And minus 1 times b is minus b. C times 1 is plus c. So we now have 1 equal a minus b plus c. However, we had already found the value of a as minus 1 over 4 and the value of c as 3 over 2. So we'll just put the values down here. So 1 is equal to, what is a? A is minus 1 over 4 minus, what is b? B is not known, plus c. What is the value of c? 3 over 2. So we'll now work this out to find the value of b. So the LCM here, this is b over 1 if you like. The LCM here is 4. So that 4 divided 4 is 1. 1 times minus 1 is minus 1. minus 4 into 1 is 4. 4 times b is 4b, plus 4 into 2 is 2 times 3 is 6. So we simplify that, we're going to have, so I'm taking it up now, we're going to have 1 left hand side is equal to minus 1 plus 6 minus 4b over 4. So 1 is equal to minus 1 plus 6 is 5 minus 4b over 4. So if I cross multiply here, I'm going to have 5 minus 4b equal 4 times 1 is 4. So that minus 4b is equal to 4 minus 5. I take plus 5 to the right, becomes minus 5. So that minus 4b is equal to 4 minus 5 is minus 1. So to get the value of b, I'll divide both sides by minus 4. Divide both sides by minus 4, so that minus cancel minus, then b is equal to 1 over 4. So the values of a, minus 1 over 4, b, 1 over 4, c, 3 over 2. We'll now go back to our partial fraction and substitute the values accordingly. So we had 2x plus 1 over x plus 1 into x minus 1 all squared as, as this. Now the values of a, b, and c have been found. So we go back to put them there. So we now have 2x plus 1 over x plus 1, x minus 1 all squared equal to, what is a? Our a is negative 1 over 4 all over x plus 1 plus b. What is b? Our b is 1 over 4 all over x minus 1 plus c. What is our c? Our c is 3 over 2 all over x minus 1 all squared. And of course, we can tidy this up one more time to get minus 1 over, this 4 will come down into x plus 1 plus 1 over this 4 can come down again, x minus 1 plus 3 over the 2 comes down as x minus 2 all squared. And what you have here, 2x plus 1 over x plus 1, x minus 1 all squared. So this compound fraction has been splitted now into, partial fractions. And in this case, there are 3 terms that make up the partial fraction. So this was an example of case 2. We'll now take another example of case 3 and see how we work it out. So what this means is that if you simplify this fraction now, if you simplify these 3 simpler fractions, what it gives to you is a compound fraction if all we have done is in example 3. Split 2x minus 2 over x squared plus x plus 4, and the second factor is x plus 2 into partial fraction, PF, partial fractions. So solution, we have 2x minus 2 divided by x squared plus x plus 4 into x plus 2. So we must ask ourselves a question. There are 2 factors here. The first factor is quadratic. Why? Because the highest power of x is 2. Second factor is linear. However, like I said, once you have a quadratic factor, the first thing you must ask yourself is, can this quadratic factor be factored or factorized? Rather. So if your answer is yes, you go ahead to factorize it. If your answer is no, you leave it the way it is and you apply rule number, or you apply case number 3. So x squared plus x plus 4, is it factorizable? The answer is no. And of course, for the case of quadratic, it is even easy to check. Now, if you've been following up my videos, then there's this thing called discriminant. You can use it to check if you're not too sure. So we have x squared plus x plus 4. Discriminant is what? B squared minus 4ac. You want to know if this quadratic expression is factorizable or not. Check the discriminant. And if you check it and you have anything that is less than 0, that is negative, this tells you that this quadratic expression cannot be factorized. Let us see. What is our a here? Our a is 1, our b is 1, and our c is 4 from quadratic equations. So that b squared minus 4ac, b is 1, so 1 squared minus 4 times a is 1, times c is 4. So 1 minus 4 times 4 is 16. 1 minus 16 is negative 15. So this is less than 0. So once you test your discriminant on a quadratic factor and you have anything that's less than 0, this tells you that that expression cannot be factorized. That's just one way of knowing. Okay, let's go ahead. So we have seen now that we cannot, factorize this expression. Therefore, what do? We apply case 3. So we split. The first factor, our first factor is what? X squared plus x plus 4. Since we have agreed already, we have seen clearly that this cannot be factorized. We leave it like that. Plus our second factor is what? X minus 2. We now sort out what should be, at the numerators of each fraction. So here, this is a polynomial of degree 2. So what should be up? Remember, it has to be a polynomial that is 1 degree less than this. So this is degree 2. Here has to be degree 1. So degree 1 will look like ax plus b. That's degree 1. Because the highest power of x is 1. When I move over here, this factor here is linear. And so the highest power is 1. So what should be here? Must be degree 0 polynomial. We have already used a and b. So we can just write here plus c. So we have splitted them. We have decomposed this compound fraction into, its partial parts, of which we have to determine the values of a, b, and c. Like we have always done, like we did in the first 2 cases, I will sort out my denominators first before I proceed. So I'll multiply everything by the denominator, x squared plus x plus 4 into x plus 2. I'll do the same here. I'll multiply this by x squared plus x plus 4 into x plus 2. I'll multiply here also x squared plus x plus 4 into x plus 2. Okay, this is plus 2, beg your pardon, into x plus 2. So with this factor will knock this off. This other factor knocks this one off. This will knock this off. This will knock this off. And I write down what I have. I have 2x minus 2 equal to ax plus b into x plus 2 plus here I have c into x squared plus x plus 4. So I like to call this again my equation star. And like I said, at this point we are very free to solve using any method of your choice. In this particular example, I shall introduce 2 ways of proceeding from equation star. So I'll now check out to see if I can make any of the brackets to be 0. Let's see. I've seen one here, x plus 2. So if I put x plus 2 equal to 0, I'll have x equal to minus 2. So I'll put here x equal to minus 2. Because once I have 0 somewhere, it will help, simplify the expression and I can get some terms. So left hand side is 2, x is now minus 2. So minus 2 here equal to a minus 2 plus b minus 2 plus 2 plus c into x is minus 2. So this is minus 2 squared plus minus 2 plus 4. Good. So 2 times minus 2 is minus 4 minus 2 equal. So here minus 2 plus 2 is 0. And once here is 0, whatever this will be times 0 is also 0. Plus c into minus 2 all squared is 4. Plus times minus 2 is minus 2 plus 4. So I have minus 4 minus 2 is minus 6 equal to, this is 0. So this is c into 4 minus 2 is 2. 2 plus 4 is 6. So I have minus 6 equal c times 6 is 6c. So if I divide both sides by 6, I will get that what? I will get, therefore, c is equal to what? Minus what? 1. So I will get c as minus 1. So the value of c has been obtained. Let us see if we can obtain some other value. So let's go back to our equation star. Let's see. Okay. I want to now put x at 0. I want to put x at 0 because if I put x at 0, I will have 0 times a will be 0. So this will at least, a will at least be gone. With that, I can simplify further. So into equation star, I want to now put x as what? 0. Left hand side becomes 2 into 0, x is now 0, minus 2 equal a times 0 plus b into 0 plus 2 plus c, x is 0, so this is 0 squared plus 0 plus 4. We'll simplify carefully. 2 times 0 is 0. What is left on the left is minus 2 equal a times 0 is 0. What is left there is b. So b, 0 plus 2 is 2. Plus c into 0 squared is 0. 0 is 0. This is 4. Plus what? 4. So we now have minus 2 equal to 2 times b is 2b plus c times 4 is 4c. You should recall that we already have our c as what? Minus 1. So we have c already as minus 1. C is equal to minus 1. So we now replace c here with minus 1. We have minus 2 into 2b plus 4. Our c is now negative 1. So that becomes minus 2 equal 2b. 4 times minus 1 is negative 4. We'll now find the value of b. So this is minus 2 minus 4 to the left becomes plus 4 equal 2b. So that minus 2 plus 4 is 2 equal 2b. If we divide both sides by 2, we now have our b equal to what? 1. So we have the value of b now as 1. So we have c as minus 1 and we have b as 1. What is left? Let us see. We found the value of, we found b, we found c. What is left is a. And we have seen clearly that there's no other place to put, to make it 0 here. So, like we did in the second example, we'll just put x to be a very simple number that will be easy to handle. So let us see. In the first, instant, we had put x to be what? Negative 2. In the second instant, we now put x to be what? 0. So I would like to put x down to be 1 to make the job very easy for me. So I'll now put x equal to 1 into equation star. Please take note. Let me emphasize. At this point, I can put x to be 1 over 2, x to be 3, x to be whatever it is you like. However, bear in mind that, the bigger this number is, the more complicated, your simplification becomes. So it's advisable to always put a number that makes the work easier for us. So in this case, I take x equal to 1. Any other choice of x will still do the same job. So, left hand side, I have 2 into 1 minus 2 equal, I have here a into 1 plus b, x is 1, 1 plus 2 plus c, x is 1, so 1 squared plus 1 plus 4. So 2 times 1 is 2 minus 2. Then a times 1 is a plus b. Outside 1 plus 2 is 3 plus c into 1 squared is 1 plus 1 plus 4. So 2 minus 2 is 0 equal, we have a 3 into a plus b plus c into 1 plus 1 is 2, 2 plus 4 is 6. So we have 0 equal to 3 into a plus b plus 6c. If we open up the bracket, we have 0 equal 3 times a is 3a plus 3b minus 6c. However, we have found already that our b is what? 1 and our c is minus 1. So we come back here, we have 0 equal 3a plus 3. Our b is what? 1, 6. Our c is what? Minus 1. So this gives us 0 equal 3a plus 3 times 1 is 3. 3 times minus 1, 6 times minus 1 rather, is minus what? 6. So that 0 is equal to 3a. 3 minus 6 is minus what? 3. So this implies that if we take minus 3 to the left, we have 3 equal to 3a. So that if we divide both sides by 3, we get our what? We get our a to be equal to what? By 3 rather, a equal to 1. So we have gotten the values of a, b, and c. We'll now go back to our partial fraction to put those values in. So now we go back to our partial fraction. So a is now 1, b is 1, c is minus 1. So this compact fraction, now becomes a is 1, so that is 1 times x is x, plus b is 1, so x plus 1 over x squared plus x plus 4, plus c is minus 1 over x plus 2. So we can write it up finally now as, so say 2x minus 2 divided by x squared plus x plus 4 into x plus 2 is equal to x plus 1 over x squared plus x plus 4, bring this minus in, minus 1 into x plus 2. And this becomes the partial fractions to our compound fraction. Now, like I said earlier, I want to now show you another way you would have approached, solving this from equation star. In this method, we are going to expand the right hand side of equation star as follows. So ax times x is ax squared, ax times 2 is plus 2ax, b times x is plus bx, b times 2 is plus 2b, second bracket, c times x squared is plus cx squared, c times x is plus cx, and c times 4 is plus 4c. We'll now take like terms. Now we have x squared term here, so this is x squared term. So this is quotient there is a. Another one, yes, there's another one here. Quotient is c plus c. So that x squared times a is ax squared, and x squared times c is cx squared. The next one is the x term. There is x here, so we have 2a as a coefficient. There's another x term here plus b. There's another x term here plus c. So that x times 2a is 2ax, x times b is bx, x times c is cx, plus the terms that have no x. The first one is 2b, 2b has no x. Second one is 4c plus 4c. So left hand side is 2x minus 2. Having gotten to this point, you now do what you call, you now compare coefficients. Compare coefficients. Very simple. You expand the right hand side completely and now take like terms according to their powers. The ones with x squared are put together, the ones with x are put together, the ones without x are also put together. We now compare coefficients on the left and on the right. Now we have x squared here, we have x, and we have the constant term. So the first thing we want to compare are the coefficients of x squared. So x squared. So here x squared has coefficient a plus c rather. So a plus c is the coefficient of x squared. On the left hand side, there's no x squared. See it here, we have x, no x squared. So left hand side is 0. So a plus c is equal to 0. That gives us our first equation. And we'll now compare the next coefficient, which is x. The equation of x here is 2a plus b plus c. On the left hand side, there is x. And the equation of x is 2, equal to 2. Equation 2. They now compare the constant terms. That's a term without x. On the right hand side, 2b plus 4c has no x. So 2b plus 4c has no x. On the left hand side, minus 2 has no x. Minus 2 here has no x. So we have 3 equations now to be solved simultaneously. And of course, at this point, there are different methods that can be used to solve these 3 equations. So I'll solve this very quickly. Let's see. So we have a plus c. Here we have a and c. We have a, b, and c. We have b and c. They're all different, they're not consistent. So what I'll now do is I'll try to make 2 equations to have exact, to have the exact, letters. Then I can solve. So from equation 1, from equation 1, okay, here I can rewrite 1 as a equal to what? Minus c. Since a plus c is 0, if I take c to the right, I'll have a equal to negative c. So that I can substitute a equal to minus c into equation 2. So I can put that value of a into 2. What am I seeing? If I put this into 2, I will have 2a plus b plus c equal to 2. So wherever I see a, I put minus c. So that becomes 2 into minus c plus b plus c equal to 2. So that 2 times minus c is minus 2c plus c plus b equal to 2. So minus 2c plus c is minus c plus b equal to 2, which I choose to write as b minus c equal to 2. So I call this my equation 4. Now what do I observe? I observe that equation 3 and equation 4 have exactly the same letters, b and c, bc. So I'll now solve 3 and 4 together. So 3 is 2b plus 4c equal to minus 2, while 4 is b minus c equal to what? 2. So I'll now solve these two equations, simultaneously. I'll use a method of substitution. So this is equation 3, this is equation 4. So from 4, I have that b is equal to what? 2 plus c. I call this equation 5. So if I substitute 5, so substitute equation 5 into 3. I'll have, what is 3? 3 is what? 2b plus 4c equal to minus 2. So wherever I see b, I'll put 2 plus c. So I have 2 into b, then becomes 2 plus c plus 4c equal to minus 2. So 2 times 2 is 4. 2 times c is plus 2c plus 4c equal to minus 2. So 2c plus 4c is 6c equal to minus 2. This is plus 4 to the right becomes minus 4. So that 6c is equal to minus 2 minus 4 is minus 6. If you divide both sides by 6, you get that c is equal to minus 1. And that corresponds to what we had, using the previous method. So now I have c as minus 1. I'll now substitute the value of c. I'll now substitute c equal to minus 1 into, my equations. I can put into 1. I can put into any one. So let me put into 5 first. So I put c into 5. If I do that, I'll now get, what is 5? See 5 here. 5 is what? b equal to 2 plus c. So 5, c is minus 1. I have b equal to 2. C is minus 1, minus 1. So b is equal to 2 minus 1 is 1. So I found out I've gotten my value of b also, b equal to 1. I have c as minus 1, I have b as 1. So I now have to find the value of a. So I come back to equation number 1. Look at what I have here. I have here a equal to minus c. I have here a plus c. I can use any of the equations to find the value of a, but I take the simplest case, which is this. I already have here that a is equal to minus c. So a is equal to minus, what is c? C is minus 1. So a is equal to what? Minus 1. So a is equal to minus times minus 1 is plus 1. Therefore a is equal to 1. What do we observe? We found out that our a again is 1, our b is 1, and our c is negative 1. And this agrees also with the previous method we had applied. Now just to wrap it up again, this method here, what we have simply done is this. We go back to equation star, we expand the right hand side of star. After doing that, you now take the like terms in terms of power. So here we put the ones with degree 2 together, the ones with degree 1 together, and the ones without x at all, the constant terms, we put them together. We now compare the coefficients on the left and the right hand side. Now on the right hand, the first coefficient you compare is the one of x squared. Then what is standing by x squared is a plus c. See it here. On the left hand side there is no x squared, so equal to 0. We now move to the x coefficient, which is 2a plus b plus c. This is it. On the left there is x, and what is the coefficient of x is 2, equal to 2. Second equation. And the next is a constant term, the term without the x. So 2b plus 4c equal to here minus 2 has no x, we equate to minus what? 2. And then this gives us what? We have 3 equations to be solved simultaneously. At this point, you can apply any method that you already know before now to solve. So I just use a very simple approach here to solve. So if you follow the solutions carefully, I'm sure you'll understand it. However, you feel free, you're very free to use any other method that best suits you at this point to solve. So that is how we go about partial fractions. Whatever you see next is just a combination of 1 or 2 of the cases like we've done. Please don't fail to leave a comment and like on this video. Thank you and bye-bye.